In this video, I'm going to talk to you about some of the symbols used in logic, called logical operators. This first symbol is called a negation. A negation changes the truth value of a statement to its opposite meaning. For example, if proposition P is true, then the negation of P is false. The negation of P is defined by the following truth table. Here we have P. Here we have the negation of P, true and false. So when P is true, the negation of P is false. And when P is false, the negation of P is true. The next logical operator I'll show you is called a conjunction. And we use the following symbol for conjunction. It looks like an arrow pointing up. A conjunction is sometimes called an and statement. So this is a conjunction. It's an and statement. In logic, the conjunction of two propositions, P and Q, is true only when both P and Q are true. So I can define the statement P and Q using this truth table. I'll make a column for proposition P and a column for proposition Q. So here, I'll set up my truth table, true, true, false, false. My truth table has 4 rows because I'm working with 2 propositions. True, false, true, false. P and Q. So, as I said, the conjunction of 2 propositions, P and Q, is true only when both P and Q are true. So if I look at this first row here, I see that both P and Q are true. That means statement P and Q is true. For all other scenarios, P and Q will be false. Here, P is true, but Q is false, so this must be false. Here we have false and true. That renders this statement false. And here we have 2 false statements, so P and Q will be false here as well. The next operator I'll show you is called a disjunction. A disjunction is sometimes called an or statement. So this is a disjunction. And you can see it looks like an arrow pointing down. Or statement. In logic, the disjunction of 2 propositions, P and Q, is true in all cases except for the case when both P and Q are false. And I can use the following truth table to define that statement. So proposition P, proposition Q. Here we have statement P or Q. So again, I'll set up my truth table. True, true, false, false. We have 2 propositions, so we use 4 rows. I alternate here, true, false, and then I evaluate. P or Q, both statements are labeled true here, so P or Q must be true. True or false? Well, one is true, so that makes the whole statement true. False or true? Again, there's one true, that makes the whole statement true. And finally, false or false. This is the only case in which my statement P or Q will be false. And so that's statement P or Q. False only when both proposition P and proposition Q are false. So let's look at a different kind of logical operator called an implication. An implication is sometimes called an if-then statement. Implication. And it's characterized by an arrow symbol. sometimes called an if-then statement. And an implication reads as P implies Q, or if P, then Q. So it could be written as P implies Q, P implies Q. Okay. For an implication, it will be true in all cases except for the case where P is true and Q is false. In other words, if true, then false is the only false statement when you're working with an implication. So let's set up our truth table to illustrate this. We have P, Q, if P, then Q, or P implies Q, whichever you prefer. And I'll set up my truth table. True, true, false, false. We'll alternate true, false, true, false, and now we will evaluate. So when proposition P is true and proposition Q is true, the implication if P then Q is also true. When P is true and Q is false, if P then Q is false. The implication is true in all cases except for when P is true and Q is false. Now, when P is false and Q is true, if P then Q is still true. And when P is false and Q is false, if P then Q is true. And so this truth table illustrates the definition of an implication. Next, let's look at a statement called the biconditional. The biconditional is characterized with a double arrow symbol. This is the biconditional. A biconditional reads as P if and only if Q. So it's an if and only if statement. So you might see P if and only if Q. IFF is mathematical shorthand for if and only if. Or you might see P if and only if Q. The statement P if and only if Q is true when both P and Q are true, or when both P and Q are false. We'll define it again with a truth table. Here's proposition P, proposition Q, and here we have the statement P if and only if Q. So we'll set up column P, column Q, and like we did before, we'll evaluate each statement. So when P is true and Q is true, P, if and only if Q, is also true. When P is true and Q is false, the biconditional statement is false. When P is false and Q is true, that's another case where the biconditional statement is false. And when P is false and Q is false, the biconditional is true. And so this truth table defines the biconditional. So there it is, just a few basic definitions for some common logical operators.